Okay, we're in section 1-5, solving inequalities. And we're first going to look at solving an inequality using addition or subtraction. Now this corresponds to page 34 in your textbook. This is example 1. We've got a couple of examples here we're going to work through. Now, again, that's on page 34 in your textbook, example 1. So I'm looking at this first one here, and this is 5w plus 3 is greater than 4w plus 9. And as I approach this, I want to get my variables on one side of the inequality, and I want to get my constants on another of the inequality. And so I identify my variables. Here's one, 5w. Here's another, 4w. And my constants are 3 and 9. And so in effect, I am combining like terms. I'm just going to put my variables on the left side of the inequality. I tend to like to put my variables on the left side of the inequality, or equality as the case may be, but right now we'll work in inequalities. And I'm going to get my constants on the right. And so in order to do that, I am going to subtract 4w from both sides of the inequality. And I am going to subtract 3 from both sides of the inequality. All right, so I hope we get what I got there. I kind of put that all in one step. And so if I subtract 4w from 5w, I'm going to have w. And I can see here that my 3's are going to cancel. My 4w's on this side are going to cancel. And so I'm left with w is greater than, and I got 9. I'm subtracting 3 from 9. 9 minus 3 is going to be 6. So w is greater than 6. Now the second step in this is where I'm being asked to graph this on a number line. So I've got a number line here, and let's plug in, let's say that this is 0. And let's say right here on the number line is 6. Now the first question I've got to ask myself on graphing this, am I going to be using an open dot or a closed dot? Well, since this is just simply a greater than and not a greater than or equal to, so let's go over the rules. If the inequality is less than or greater than, I'm going to use an open dot. And if it is less than or equal to, greater than or equal to, I'm going to use a closed dot. So I got an open dot right here at 6, meaning that w does not equal 6. It just approaches as close as it can to 6 here on the number line. And then the second thing is, which way am I going to extend my solution set on this number line? And so we're greater than 6, so I'm going to be going out here to the right of my open dot. And there I've graphed on the number line, w is greater than 6. We solved an inequality using addition or subtraction. In this case, we use subtraction. Not too bad. All right, so let's look at a second example coming from page 34 on the textbook under the example 1 guided practice. This is number 1b, where we've got 5x minus 3 is greater than 4x plus 2. So again, as I approach this problem, I want to get my variables on one side of the inequality. I want to get my constants on the other. My variables here are 5x and 4x. My constants are -3 and 2. I prefer and want to, and I think you should, get your do everything you can to get your variables on the left side of the inequality, your constants on the right. And so let's go about doing that. So I'm going to start here by subtracting 4x from both sides. And if I want to get my constants on the left side, I'm going to move this -3, and in order to do so, I'm going to add 3 to both sides. Okie dokie. All right, so let's then here begin to solve. If I am subtracting 4x from 5x, I'm just going to be left with x. Still going to be greater than. I see here that my -3 and my +3 have canceled out. My 4x and my -4x have canceled out. And I'm going to simply add 2 plus 3, which I know to be 5. And so x is greater than 5. And so we're going to take our second step and graph this solution set on the number line. Let's say 0 is sitting out there, 5 is right here. And so again, I'm going to ask the question, am I using open dot or closed dot? Open dot or closed dot? Well, it's a greater than, not a greater than or equal to, so it's going to be an open dot. I'm going to put a little open dot right there. I am dealing with a greater than, so that means I'm going to be moving from that open dot at 5 to the right. That symbolizes things greater than. And so this is the solution set where x is greater than 5. We have solved this inequality. This is called a one-step inequality, as was the other, using addition or subtraction. Shazam! How about it?